Hi everyone, thank you and welcome to the 24 Hours of PaaS Summit Preview 2016. We're excited you could join us today for Matan Youngman's session, MongoDB for the SQL Server Professional. This 24 Hours of PaaS event consists of 24 consecutive live webinars delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hoursofpaas.com for the links. My name is Douglas Murillo, a PaaS enthusiast from Costa Rica. I have a few introductory slides before I hand over the reins to Matan. Let's continue to the next one. All right. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the QA portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Idera, and Attunity. In addition, I'll also like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise and SQL Sentry. The staging of 24 Hours of PaaS will not be possible without their generous support, and they are the reason this event is available free of charge. Make sure you explore everything else PaaS has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. Next, I would like to bring your attention to the upcoming PaaS Summit taking place in Seattle, Washington from October 25th to the 28th. The PaaS Summit 2016 will feature over 200 sessions with world-class data experts. It's like the perfect place to network with experts and peers, and you can meet the Microsoft engineering team behind SQL Server 2016. Save $200 on registration by using the exclusive discount code on the slide before the end of Sunday, September the 18th. To find out more, visit www.paassummit.com. All right. I would like to introduce today's presenter, Matan Youngman, CTO of Madeira Data Solutions. Matan is an MVP of Data Platform and the co-host of SQL Server Radio. And without further ado, here's Matan with MongoDB for the SQL Server Professional.
Okay, thank you, Douglas, and good morning, good evening, good afternoon, and good night, everyone, and thanks for joining me. Before I start, just as Douglas said, I work for Madeira Data Solutions. We're an international consulting company, and I co-host SQL Server Radio, which is a podcast for SQL Server professionals. I co-host it with Guy Glanzer, who presented yesterday, and a podcast is a nice way to learn while you're doing other things, when you jog or when you commute to work, or when you wash the dishes, and so on and so on. So if you haven't tried it yet, try it and maybe you like it. But today we're not here to talk about SQL Server, or not only about SQL Server. We're here to talk about MongoDB. And MongoDB is a NoSQL database, and like some of you may have heard, many projects go from SQL Server and from relational databases to NoSQL systems. And I wanted to talk a little bit about this and answer the questions of whether we as SQL Server DBAs will be out of jobs in a few years. And the answer, to be short, is no. We're not going to be out of jobs, but it's important for us to understand and know what NoSQL is and a little bit about other NoSQL systems in order to understand when they're needed, when a SQL Server solution is needed, and in order to be able to talk to NoSQL people and to developers in their own language. So let's talk about where we came from. So about 40 years ago, code went out with the relational model and the idea for the relational database. At around in 1970, Edgar Code went out with this paper, and then DB2 when Oracle started developing relational databases, and then came SQL Server and so on and so on. And basically for most of those 45 years, we've been doing everything with relational databases. We modeled everything for tables, and everything was in it, whether if it was fit to a relational database or not. But especially since the start of the millennium and when the internet came out booming, things slowly started to change. And they started to change in terms of volume. Our databases are much bigger today than they were just a few years ago. We have to store all kinds of data. So let's imagine how big the database of Facebook is. Now, obviously, they have all kinds of databases, but let's say they have a MySQL database. It's probably pretty big. And starting from a certain point, a relational database is hard to scale and hard to work with these volumes. Another thing is the variety. We have all kinds of data sources. We have internet data and forms and talkbacks and social media and stock data and streaming data and so on and so on and so on. And not everything fits inside a relational database. Let's say we have a gas pump that sends sensor data to our system. Is it really good to store that inside a relational database and then report that? Or if we want online data, maybe we need to use some kind of streaming technology to show that. Maybe that's better than a relational database. And also in terms of velocity, data comes very, very rapidly today. Let's imagine the database of Twitter. During 24 hours plus many tweets and all kinds of, again, spatial data and with very, very rapid pace. And that's hard for relational database to keep up. So maybe we need some other solutions. Another thing that came out is cloud computing. Started at around between 2002 and 2005, Amazon came out with the concept of cloud computing. It sounded weird at the start, but now we're at the stage where it's pretty weird to order your own computer, right? Let's say you need a new server. At the old times, you needed to order the server, and then it would take it a few months to get to your data center, and then you had to install it, and so on and so on. And it's a pretty expensive project that takes a lot of time. And today you can just log into Azure or Amazon, and in a few minutes you have a machine. So so that's a much more approachable concept in servers. And also there are all kinds of new services in the clouds that we're not able to deliver on-prem, like Azure SQL Database and all kinds of other services in the cloud. And another thing is distributed computing. At some point, the understanding that a few computers, even if they are relatively slow or relatively weak, can be more beneficial and can do much more work than a single computer, even if this computer is very, very strong. So if inside SQL Server, let's say we have a very big load and SQL Server can't keep up, what can we do? The easy way is to scale up. Just throw money at the problem and just buy a bigger server, a stronger server, more RAM, more CPU, faster disks, and so on and so on. But there are other solutions like Hadoop or other NoSQL systems that can leverage the power of distributed computing. Just send a command to 100 computers, each computer will do his own job, and then return the answer to the client, we can use that as a batch processing system, and so on and so on. So as we can see, the world is much more scattered today than it was 10 or 15 years ago. Also, new data models came out. Again, not everything is best modeled using the relational model. Today we have key value stores and document stores like MongoDB and graph stores. Let's say we want to model our Facebook wants to model our relationships to friends of friends, and from the second degree and third degree and fourth degree and so on and so on. So that's something that is very complicated to do inside a SQL Server database, because we will get to all kinds of weird joins to our tables and so on and so on. And a graph database that sits on top of the graph theory will work much better than that. And those databases not always conform to the old rules. And I always like to show this tweet that MongoDB announced 10 million downloads, or as the other two partitions reported, 9 million something something and 10 million and something something downloads. Now that sounds funny. I laughed when I saw this tweet at first, but that's okay, because that's the concept of eventual consistency, and we'll talk about it a little bit in the rest of the session. So even though that's funny, that's actually okay in today's world. So when I heard about those data models, and I started to see projects going out of SQL Server to other NoSQL solutions like MongoDB or the cloud or Hadoop and so on, I went through the 5 stages of grief. At first, I didn't really want to hear about it. I didn't know what it is. I didn't care what it is. I said everything can be done in SQL Server. Anyone that does that using another solution is doing it wrong. After that there came anger. After that, some kind of bargaining, then depression, and then acceptance. And then after you go through those stages, you understand that there is a place for both SQL Server and relational databases and NoSQL databases. And NoSQL databases aren't going to replace SQL Server or relational databases. They have those the use cases, and SQL Server has its use cases. And in most cases, in most places, there's some kind of hybrid solutions between those solutions, and there is a movement for architecture which uses small tools and small databases, each for which its own use case. So let's say SQL Server will be used for transactional processing and systems that need the ACID properties and log transactions and so on and so on. And MongoDB will be used for other scenarios, and graph databases will be used for other scenarios, and so on and so on. And when you come to this acceptance, you're more open to learn other solutions. And as I said,
Okay, one moment. It seems like we lost Nathan's audio. One moment, please. Hello, everyone. We're having audio difficulties at this time. We're working with a technical team to fix this. Hang on for a few seconds till we solve this.
Hello, Douglas.
Yeah, hi, Matan.
Hi.
We can hear you now.
Oh, yeah. Sorry about that. So when did you lose me?
Right at the SQL is not that
Okay.
beginning of that slide.
Okay. Great. So sorry about that. Let's repeat that slide. Okay. So when you come to the acceptance that SQL Server and other solutions can live side by side, then you understand that it's nice to learn about other solutions and to talk about with developers about those solutions and understand why they want to use those solutions. And actually, those solutions aren't that different. For example, MongoDB replication is just like always on availability groups in asynchronous mode. And MongoDB has something that is called the journal, which is just like the SQL Server transaction log, and so on and so on. So there are differences. We need to learn new things, but not everything is that difference. So let's talk about the relational data model and its challenges. So we have structured data, we have tables, rows, columns, well-defined data types. We have to define the columns and their data types in advance before we insert data to the table. We have relationships, joins, and we have transactional consistency in order to make sure that the database state is always consistent. And let's say me and my wife have a joint a bank account, and we go to the ATM and want to get money. But we can't go to a negative balance. And let's say we have $200 inside in the bank, and each of us at the same time wants to take out those $200. So in other solutions, we may be able to get that. Inside the relational database, we won't be able to do that, and that's intended, of course, in order to maintain this consistency. And of course, we have the SQL language, which we all love, I guess. I fell in love in the T-SQL language at around 2001, 2002. I've been working with it since, but not everyone loves the SQL language. Now the challenges. And the relational model only supports structured data. We do have the option to work with JSON starting SQL Server 2016 and XML starting 2000 and then 2005, but it's not structured data. It's not ANSI. And the relational model supports only structured data and not semi-structured or unstructured data. And schema modifications are hard. Let's say we have a 1 billion row table. It's hard to add columns to the table after we created it and after we populated it. And it doesn't scale very well. It's hard to set up replication or availability groups and so on and so on. And it's hard to distribute the load between the servers. Obviously, it's possible, but it's not that easy. And one of the foundations of the NoSQL movement is the CAP theorem. And this theorem says that among the three properties of consistency, availability, and partition tolerance, in a distributed system, it's only possible to get the two of them. So only CP, consistency and partition tolerance, only CA, consistency and availability, or only AP, availability and partition tolerance. And it's a very, very complicated subject, and there are all kinds of nuances for this subject. But the important part is how your system behaves when you relate to consistency. How consistent do you want your system to be, especially if you have all kinds of issues in your network. And the important part from this theorem came out something that is called the base. And it says that the system will be basically available, soft state, and the important part, eventual consistency. And eventual consistency means that, let's say I go on Facebook and post something. Is it really important that every one of my friends and everyone on earth will be able to see this the status the second I hit publish? Not really, right? On the other hand, if I have an ATM system, it's really important for the whole world to know that this person has these kinds of amount in his bank account. So as you can see, we need to start thinking about scenarios and where to put each scenario. Again, if I hit like on a post on Facebook, it's not really important that the person that posted the post will see that he has 101 likes instead of 100 likes. It can take some time for him to see that, and the idea is the system won't be consistent this right minute, but it will be eventually consistent. Eventually the information will go out to all nodes and all people will be able to see that. And if you think about it, SQL Server also has technologies that are eventually consistent, like replication and log shipping and so on and so on. So SQL Server also uses the method of eventual consistency, and also in the past, or today also had data warehouses which worked nightly, and then the information was consistent to the night before, and so on and so on. So it's not only NoSQL thing, but it's very inherent inside the NoSQL movement. So what is MongoDB? MongoDB comes from humongous DB, which means very, very, very big. Well, here in Israel, we have a burger company called Humongous. I actually don't really like those burgers, but some people like it because they have all kinds of different tastes and they are very, very big. So this is a MongoDB, and it's scalable. The option to scale the load between servers, they have two concepts of replication and sharding. Replication means that all the information goes from the primary to the secondaries, just like in availability groups, and you're able to write data to the primary and read data from both the primary and the secondaries. Sharding means that you shard your data between servers according to a certain column in your database, in your table, or what is called collections. So it's much more inherent in MongoDB than inside SQL Server. It has dynamic schema, so I can insert a document, what is called, not a row, a document to the collection that has 10 columns, let's say, and another document that has some of those columns and extra columns, so they will form 15 columns, let's say. So I don't have to define my fields in advance. it can solve some kinds of issues, like if someone knows sparse columns that was added, I believe, in SQL Server 2008 for all kinds of, let's say, we have items that have color and size, and some items have color, size, and price, let's say. So sparse columns came to solve the problem of extra storage. So in MongoDB, it's much more inherent. I can just insert a document that has some of the columns, but not all of them, and we'll see that in the demo later on. MongoDB doesn't have joins, and this is one of the factors that allow it to scale very well. Because let's say I would take a SQL Server database and shard it. And then I want to make joins between tables on different charts. This means that lots of data needs to go over the network, and that slows things down. So if you don't have joins between your tables or collections, then things are much faster because you don't need to transfer data over the network. And now MongoDB does have those concepts because sometimes we do need them. They're called embedding and linking, and we'll talk about it. MongoDB doesn't support complex transactions, so each and every insert from MongoDB is doable and basically atomic. But let's say you have to insert 1 million documents, you can't do this insert of those 1 million documents in a single transaction. You can do that in SQL Server. You have complex and long transactions in SQL Server. You don't have this concept in MongoDB. They're actually considering it now, but they don't have it up till now, so it's up to us to verify that all the information that was that needed to be added was indeed added to the table. And it has drivers for many languages, C# and Java and Python and so on and so on. And it's very appealing to developers. And I think this is the strongest and the most important factor for the rise of MongoDB and NoSQL systems. As we said, probably everyone in this virtual room loves SQL, loves the SQL language. Not every developers, many developers don't like SQL, and it's more native to them, both in terms of the data types and the data model, and in terms of the programming language itself. So why more native? Let's look at this small schema inside the AdventureWorks database. Within 5 minutes of modeling this, we have 1, 2, 3, 5, 6, 7 tables. And this is even not all of the tables inside this, this production schema. I just added the tables that could fit in the screen. So it's very complicated to get your head around this data model, because you have to go to product and then product model, product document, and so on and so on. And you have to understand the schema, and then you have to write queries that have lots of joins and so on and so on and so on. And it's sometimes hard, even for us with many years of experience in SQL Server, it's sometimes hard to understand those complex schemas. And in MongoDB, the data model is come as you are. Just everything goes in, and it's much more native to developers. And when they hear that, they just go woo, and they're in shock, and they're very, very happy. Now, again, not all developers. There are lots of developers who love SQL and love SQL Server, but there are many, many developers, maybe more developers that don't like SQL and like other solutions. That's why we have ORM, Object Relational Mapping, like an Hibernate, an Entity Framework. And developers don't like, many developers, again, don't like the relational model, and they need some kind of translation between their classes in the application to the relational model. And now they don't even need that, because they work in MongoDB much more natively than they work with SQL Server. But before jumping to MongoDB, hold your horses or hold their horses, because as we said, MongoDB isn't good for every solution, and in general, every NoSQL solution and every solution in general isn't good for every problem. So there's something that is called the Dunning-Kruger effect, and what it says is that our confidence is bigger before we understand something. So when we are very, very novice or very, very new to a new technology, we hear only the marketing hype, and we tend to think that this will solve all of our problems. But as we start learning and understanding and become an expert, our confidence gets lower, and this effect leads to some very poor choices with technologies. And I've seen many companies that chose the wrong technology because it was supposed to be the next big thing that will solve everything, and they went and did a project, and 1 or 2 years afterwards they ended up with an improper solution and had to redesign it, and that cost them much more money than it would cost them to model that the right way. So know the technologies, and this is another reason to know MongoDB and NoSQL solutions in order to prevent your company and your managers and your technical leads from choosing the wrong technology for the wrong solution. Having said that, let's start talking about MongoDB and some terminology. So a SQL Server database is mapped to a MongoDB database. A table is mapped to something that is called a collection, and a row is mapped to something that is called a document. So a table is a collection of documents inside a MongoDB database. And we have other things in the terminology. A database is a database, a table is a collection, a row is a document, an index is an index. MongoDB uses B2 indexes like SQL Server does, and joins, as I said earlier, they have the option of embedding. I can embed a document inside another document. And I have the option of linking, and linking means that let's say I have to hold the document in another collection, so I can link to the ID, to the quote-unquote primary key of this document from another collection. And by the way, some hybrid solutions use MongoDB, but they save the primary key of a row inside the SQL Server database, so they can interact with each other, and so on and so on. So linking is not only to MongoDB, it's in the MongoDB terminology. Linking is to another collection, but I add linking to relational databases also for hybrid solutions. Now I'd like to meet JSON, and JSON is a JavaScript object notation, and this is the basic programmatic part, or the basic unit of work inside MongoDB. And if some of you are developers or know a little bit about programming, it looks kind of like a class or a struct, and again, it's much more native to developers. So what we have here is all kinds of fields, and we also have the option for embedding a document inside our big document. This is our big document, and inside the small one. And we can also have an array. So let's say we have a few, me and my wife have a few children. So we can put all of them here, an array of our children, and so on and so on. And this data model can speak much more efficiently and easily with applications and with developers than the relational model in many cases. And now we talk about the concept of normalization versus come as you are. If you remember the schema we showed a few slides ago, and as you know from your work, probably in SQL Server, we work in IKEA mode. Every time we enter the room, we assemble the chair and then disassemble. We join a few tables and get the query, and then when we insert data, we disassemble the information and spread that among a few fields, a few columns, a few tables, and so on and so on. In MongoDB, it's come as you are. You have a chair, the chair will be inserted. The chair will be divided into a few fields inside the JSON document, but it will be inserted as is. We won't have to break that to a few tables. And again, it's sometimes good and sometimes bad, but for many developers and for many solutions, this is easy, and this is quite good. And the relational model comes to help in situations where we want to make sure our data is consistent, and for a lot of other reasons. But in MongoDB, we work with come as you are, and that works for many situations as well. And with that, let's see a demo and start to get a feel of MongoDB. So what we have here is a command window, a shell window, and what we will do is hit MongoD, and our MongoDB server is running on my laptop. And now from another window, we'll type Mongo, and now we're connected to the server, and we're connected to a database called test. And now let's see which databases do we have inside our Mongo server. And we'll hit show DBs, and we can see we have a database called another test and a database called blah blah, and so on and so on. And now I want to create a new database. So the only thing I need to do is use new DB. And we have a new database, and we also use it. And we can also type use new DB in order to make sure we're using the new DB. And as you can see, it's also just like SQL Server. We can type use our new DB in SQL Server also, and we will use that. Now let's see which quote-unquote tables we have inside the MongoDB database. And we'll type show collections. And we can say that we don't have any collections up till now. So what we'll do, we will insert a table, we'll insert a new document to a new collection, and the document and collection will be created on the fly. So we'll type db.new table, SQL Server terminology, .insert, and I will type now where we started to create the JSON document. The name is Matan, the last name is Jungmann, and we close the JSON document, and we close the insert, and we have a new collection and a new row. And let's type again show collections, and we can say that we have a new table. Now let's see which rows we have inside the table. So we'll type db.new table.find, and we can see our row. And now if we hit db.new table.find.pretty, we can see that in a better shape. Something that looks better. Now we said we can use dynamic schema. So let's say I want to insert another document into the collection, but this document will have another column. So what I will do is I will insert a new collection, but I will add another field called address and type Tel Aviv. And we have another row in the collection, and we can see that that we have two documents in the collection, one with the address and one without the address. And now let's see what we can do with it. So let's say we want to find the document that has the address property, or the one where I live in Tel Aviv. So what we can do is we have two options. The first one is to use AND. As you can see, the syntax is a little weird. We're using the AND here, and we have a comma here, and we want both the name to be Matan and the address to be Tel Aviv. And we can see that we have one document like that. Another option is to check whether we have the address field, and we do that with the exist property. So I want to find the document where the address field exists. And we can see that we got the same row. Now let's say I want to relocate, let's say I work for Microsoft and I want to relocate from Tel Aviv to Seattle. So obviously we can use the update command. Let's clear the screen. And what we do here is db.newtable.update. And basically the syntax is, this is the where part. I want to update the row which I live in Tel Aviv to Seattle. And we updated, we see that we have one modified row. And now, when we use the find property, we can see that I live in Seattle instead of Tel Aviv. And now that we finished the demo, we'll drop the database. So what we can do is db.drop database. And the database was dropped, and when I hit show DBs, we can see that we don't have this database at all. So as you can see, it's very, very nice and pretty easy to start with. When we get in past summit, we'll get to something that is called the aggregation framework, which allows doing all kinds of complex things inside MongoDB with queries. It's more complicated, but it's very easy to start, for better or worse, because when it's easy to start, lots of times it's easy to do the wrong things. But it's very, very nice to start playing with it and see how it works and see how easy it is to just start playing and working with the elements. And we'll get back to the slides. So to summarize, MongoDB and NoSQL solutions in general are much more aware of scale, but I believe the main factor is the ease of development. Developers finally, after 40 years, have something to work with that is very easy to work from the application and is easy to read and interact with as developers. For us as DBAs, it's easier to work, to think in sets, in SQL Server jargon. But for many developers, it's easier for them to work with classes, with JSON documents, and so on and so on. And this is why I believe MongoDB is so successful. User appropriate, again, remember the effect I showed in one of the slides. Know your stuff. Don't go ahead and work with the wrong solution. Get to know MongoDB. Get to know Hadoop. Get to know other solutions in order for you to be able to tell your boss or to tell your developers you're doing this right or you're doing this wrong, because it's very, very important. Even if you don't work directly with MongoDB or other solutions, it's very important to know where they're appropriate and where they're not. And just start playing, and why not do it now? Just go ahead, go to the MongoDB website, download the MongoDB server and just start playing with it. It's very, very nice. And I'd like to thank you for listening, and I will now take questions if anyone has one. So Douglas, are there any questions?
Can you hear me, Matan?
Yes.
Okay, sorry. So yeah, we do have some questions. The first one will be from David. Are there MongoDB providers that can be used to establish like link servers to SQL Server?
Can you repeat the question, please?
Yeah, if there are MongoDB providers that can be used to establish a link server to SQL Server?
There are. I don't remember their name right now, but there are connectors. It won't necessarily work like a linked server, but there are providers that connect between MongoDB to other systems like Elasticsearch and yes, to SQL Server also. So I can look it up and post it afterwards in the blog, and you have the answer.
Okay, great, thanks. We also have a question from Keen. What kind of use cases have you seen that they're more suitable for MongoDB compared to relational solutions, or in this case, SQL Server?
So I won't necessarily use more suitable, because actually in most cases I've seen both of them were suitable. In the many cases I've seen, again, it was easier for developers to work with and easier for the DevOps team to form a cluster of MongoDB. It's pretty easy and it works very well. So it's a little bit easier to shard your data and scale your databases with MongoDB. So if you have a very big database that needs to be scaled, it may be easier to do that with MongoDB, but you need to take into account also the your queries and your inserts. Because again, if you have long transactions and you have to insert 1 billion rows, then you probably need SQL Server. If you can work one document at a time and you don't have these ACID properties, then go ahead and use MongoDB. Lots of times there is some kind of hybrid solutions. MongoDB, because of the lack of need to break down your data set to other tables, and then you don't need long transaction, and you don't need to map your class data, your class from the application, to SQL Server. And then you just boom, hit that inside the database, and you insert your data very, very fast. But afterwards, when you need to query the data and report the data, the SQL language is easier and to work with than the aggregation framework in MongoDB. So there are all kinds of hybrid solutions where you insert the data fast into MongoDB, transfer the data to SQL Server, and then query and report the data from SQL Server using reporting services or other reporting tools, because reporting is very, very good in SQL Server. Inserting data is sometimes a pain in SQL Server, and MongoDB usually runs faster for those inserts.
Okay, thank you. We also have a question from Michaela. Performance tuning is a concept that is very common in SQL Server. What about MongoDB? Is there always opportunity for performance tuning?
Yes, yes, there is. MongoDB does need indexes. There's MongoDB compared to DocumentDB. This is the document database solution of Microsoft in Azure. So Microsoft in DocumentDB fields are automatically indexed in DocumentDB. They are not in MongoDB. So you need to create indexes for your queries to run fast, and you need to make sure your queries are run properly. One thing developers do in MongoDB and in SQL Server sometimes is they pull the data, all of the data from MongoDB or SQL Server, and then sort or filter inside the application. So if you pull 5 gigabytes of data to your application, it's very, very slow. So, and then you need to go to your developers and say, hey, use the aggregation framework for filtering that. And you have all kinds of issues of what is called a data skew in distributed systems. It's very important to shard your data according to the right column. And if you don't do that, you can end up with one node doing all the work, and then you lose the power of distributed computing. So as you can see, there are all kinds of performance issues in MongoDB too. So there is a place for a MongoDB performance tuner, like a SQL Server performance tuner.
Okay, thanks for that. I have a question here from Ian. What will be like an average setup time? For example, setting up MongoDB and inserting millions of records. The question goes towards if it's possible to do or not bulk insert at a transactional level.
Can you repeat the last part of the question? I didn't understand the transactional part.
Yeah, if it's possible to do a bulk insert.
Okay, so setting up a MongoDB, as we can see, setting up a MongoDB server for demos is very, very easy. And if you use a MongoDB as a single server, it's very, very easy. You just download the software and run it, or run it as a service, as you should use in a proper production system. Setting up a cluster or a sharded cluster of MongoDB servers, that's harder because you have to take care of DNS and IP addresses, and sometimes you need to work with Linux, which Linux is to us Windows people is a little more complicated, and that's why the MongoDB team recommend that you use their services. They have a service that you can use for free in order to do that, in order to set up a cluster in your environment or in the cloud. And they really recommend you don't do it yourself. You just use their tools. You define whatever you want, including the server names and the addresses and the locations, and then you have monitoring and so on and so on. So it can be complicated to do it yourself. It's hard to put the number of days it will take, because if you're very proficient in it and you've done it a few times, that it will be relatively fast. But to do that for the first time, it can be quite a hassle, and it can take some time. And regarding bulk insert, I'm not sure about that. I can check that too. But generally speaking, MongoDB works row by row or document by document, and they generally don't work in bulk modes or transactional modes like in SQL Server.
Perfect. Okay, thank you very much. Those were some of the questions that we received from the audience. We're pretty much getting very close to the end of this session. So if you could move to the next slide, please.
Oh, okay. Okay.
So for everyone, make sure to stay tuned for our next session. My favorite pie chart, simple rules for clear visualizations with Marcus, Hermil, and Jensen. Remember, and thank you. Remember that they can contact you, and you also have the SQL Server Radio. That is, I went through it. It's very interesting. So make sure you go to sqlserverradio.com to check more of Maten's work and comments. And
Thank you, Douglas.
if you have any questions, please let us know, and you can contact Maten as well. Thank you very much for attending this session, and enjoy the rest of the sessions you will attend.
Thank you, Douglas. Thanks, everyone.